Today we're going to use the derivative rule in finding the derivative of a function using some table of values. Now before you can answer this type of problems in calculus, you need to first look at the table and study the table and think of what the table is giving you. So in this particular table we have the x column, we have the f of x, and f prime of x. We also have the second function, which is g of x, and its derivative function, which is g prime of x, given by these values right here. Now we're going to use this table in evaluating expressions or functions and its derivative. So let's say our first example, we have h of x, or the function h of x, is equal to f of x plus 3 times g of x. Now, in this particular problem, we are supposed to find h prime of negative 2. So in this problem, we are going to find the derivative of h of x and then replace the value of x by negative 2 after we found its derivative. So we are going to use the derivative rule in evaluating f of our function. So by finding the derivative of h of x, we'll have h prime of x, which gives us f prime of x plus 3 times the derivative of g of x, which is g prime of x. So now that we have found h prime of x, we can now use the specific value of x given in the problem, which is negative 2, and replace x by negative 2. So by doing that, h prime of negative 2 will give us f prime of negative 2 plus 3 times g prime of negative 2. And by having this function, we can now use our table of values to replace our f prime of negative 2 and g prime of negative 2 by the specific value given by the table. So let's start with f prime of negative 2. So we are looking at f prime of x table or column, and we will replace x by negative 2. So if f prime of x is f prime of negative 2, it will give us the value of 1. So f prime of negative 2 is equal to 1. And g prime of negative 2 will go to g prime of x, replace x by negative 2, will give us the value of 8. So therefore, we'll have h prime of negative 2 is equal to 1 plus 3 times 8. And by simplifying our expression here, 1 plus 24 will give us 25. And therefore, h prime of negative 2, using our table of values that is given in the problem, will give us 25. Now let's have more example. So let's say my second example is h of x equal to f of x plus g of x, given the same values on our table. We're going to find h prime of 1. So just like what we did, we need to find the derivative of h of x, which will give us f prime of x plus g prime of x. And by replacing x by 1, we'll have h prime of 1 equal to f prime of 1 plus g prime of 1. Now we can use our table in finding f prime of 1, which gives us f prime of x, replace x by 1, is equal to negative 3. And g prime of 1 will give us g prime of x, go look at 1, and it will give you 6. So by simplifying our expression, h prime of 1 will give us 3. So that is the derivative of h of x at x equal to 1 using our table. Now let's have the second example. In our second example, h of x is equal to f of x times g of x. Now, we're asked to find h prime of 0, so we need to find the derivative of our function. And we know that f of x times g of x will use the product rule, so we can evaluate h prime of x. And by the product rule, all we need to do is to find the derivative of f of x times g of x, or just copy g of x, plus f of x times the derivative of g of x. So now that we have applied the product rule, we can now replace x into 0, so we can find h prime of 0. So now we have f prime of 0 times g prime of 0 plus f of 0 times g prime of 0. And by using our table, we will replace f prime of 0 by f prime of 0, which is 9, and g of 0, so you look at g of x column and replace x by 0, and it will also give you 9. And for f of 0, you look at f of x column and it gives you 5, and g prime of 0 column, which gives you -3. So by simplifying our expression and using our table of values, we now found h prime of 0, which is equal to 66. And that is how we use the table and the product rule in evaluating functions using our derivative rule. Let's have the fourth one. Number 4, we have h of x equal to e to the x times f of x. We are asked to find h prime of 0 for this particular problem. Now, look at the function and you need to think of the rule that will be applied in finding h prime of x for this particular function. So we know that we can use the product rule for this problem. So by using the product rule, h prime of x will give us e to the x times f of x plus f prime of x times e to the x. Notice that our e to the x did not change because the derivative of e to the x is simply e to the x. And by using our table, we can now replace our x value by 0. So by replacing x by 0, we'll have e raised to 0 times f of 0 plus f prime of 0 times e to the 0. Now we're just going to use our table for f of 0 and f prime of 0 because we can easily evaluate e to the 0 as equal to 1. So f of 0 will give us 5 and f prime of 0 will give us 9. By using our values, h prime of 0 will give us 14. So this is how we evaluate h of x is equal to e to the x times f of x when we are asked to find h prime of 0. Now for this last problem that we have m of x, which is 1 all over f of x. And we are asked to find m prime of 1. So just like what we did on our previous example, we're going to think of the derivative rule that will apply to our given function. And since we have a rational function, we will use the quotient rule in finding the derivative of m of x. And the derivative rule for the quotient rule is low d high minus high d low all over low low. And by using that derivative rule, we can now replace our function by m prime of x equal to f of x times the derivative of the top, which is 0, minus high, which is 1, times the derivative of the bottom, which is f prime of x, all over f of x squared. Now, we can evaluate the derivative at 1 by replacing all our x's by 1. So we have f of 1 times 0 minus 1 times f prime of 1 all over f of 1 squared. So by replacing our f of 1 and f prime of 1 using our table, m prime of 1, or the derivative of m at 1, will give us 3 times 0 minus 1 times -3 all over 3 squared. So once again, we are just using the values that's presented to us in our given table. And by simplifying our fraction, m prime of 1 is equal to 3 over 9, and by further simplifying it, we'll have 1/3. So that's how we find the derivative of m of x equal to 1 over f of x using the quotient rule. So once again, by using a table, we can solve derivative problems by using the derivative rule like the one that I presented today.